interval is this object slowing down? C2? Where's 0?
That's 0 at 8.
Please remember this is 0. Can I go slower than 0? No. So whenever I'm heading towards 0, I'm slowing down. Whether I'm heading there from the top of the or the bottom doesn't matter. So whenever I'm heading closer to 0, it's slowing down. Whenever I'm moving away from 0, what am I doing? Speeding up. They like asking that. Then, what of this graph can I use? We can ask you for the displacement, or actually any graph you get. Always ask yourself, what does the gradient give me, and what does the area give me? So gradient is always y divided by x. So if you look at this, y is meters per second over seconds. So that gives you meters per second to the minus 2, which is acceleration if you forget. Yeah?
So going down is slowing down.
No, it's not what I said. This is 0, so going towards 0. So whether you come from the bottom to 0 or from the top to 0, it's both slowing down.
So they're moving
Don't
away
get-
from 0, speeding up.
Yes. The negative and the positive is just the direction. Don't get that confused. Area is always going to be x times by y. So this is going to be meters per second times by seconds. They cancel out, we get meters, and we know that that is going to be the displacement. If you forget, you can always quickly go and look. Now we can work, I don't actually even know. So you can work out the acceleration by saying this value minus that value. Or you can, so I don't know what else I can actually tell you. So just remember, if this is east, if they say it's traveling east initially, what is everything underneath the line going to be? West. So just remember that. So if you get a positive value, all positive values is going to be east. All negative values is going to be west. Are you happy with that? Normally we do tell you. Then we can ask you to go from here into an acceleration time graph, and we can ask you to go from there into a displacement time graph, normally. Okay, so just remember that the intervals are the same. If you've got A, B, C, D on the one, you're also going to have A, B, C, D, E, F, G on the other one. And you're just going to do it according to that. So the only thing for acceleration that you have to ask yourself, is it positive, is it negative, is it 0? So this one here is the gradient positive, negative, or 0? Positive. So accelerations are always going to be flat lines. So you know it's going to be a positive flat line for that bit there. For the next one, is it positive, is it negative, is it 0? 0. So it's going to be a flat line on 0. All the way from D to E. Is it positive? Is it negative? Is it 0? It's negative. So it's from D all the way, from C all the way to E. It's going to be negative. Next one. For E to F, is it positive? Is it negative? Is it 0? 0. So it's going to be 0. For the last little bit, is it positive? Is it negative? Is it 0? Positive. So the only thing that you could do is see this one is maybe a little bit steeper than that one. So that means this one is going to be a little bit lower than that one. You can just compare them. But that's it. Don't make it harder than it is. Just ask yourself, is it positive? Is it negative? Is it 0? Done. For the displacement time graph, I'm just going to give myself more space. Okay, I'm going to write this out because you can always go and watch it again.
Will you ever ask us to do an accurate version of those graphs?
If you've already sketch graphs normally, and if you've already worked out values, might ask you to put it in. But if you haven't worked out the values, normally we don't. So then we've got displacement time. So now think for yourself. This was all east. Did it go further west than it went east? Or did it go further east than it went west? Further east. So am I ever going to come past my starting point? So I started here at 0. I went east, east, east. I went back west. But did I ever go further west than I went east? So tell yourself that when you start, you are actually never going to go underneath the x-axis because it's never passing that point. But we still need A, B, C, D, E, F, G. Now, the one thing that you should put in for yourself immediately, everywhere where the velocity is 0, what is this one's gradient going to look like? Yeah, but not flat. Okay, so at A, I need to start with a flat line. At D, I must have a flat line again, but I've now moved west, so I know somewhere at D, it's going to be flat. And at G, it's going to be flat again, but it's not going to pass the x-axis. Okay, so I know that. Okay, so we can leave those for now because we don't know where to get. Okay, then you're just thinking, from B to C to D, am I going east or am I going west? Am I going to further from a starting point or back to my starting point? Further from my starting point east. So remember for displacement time, if I go positive, it's going to be east. If I come back, it's going to be west. But I'm only going to pass my x-axis if I go further west than I went east. So you know, from A to B, I went east. So you make a little cross. From B to C, I went even further east. So you make a cross further east. From C to D, I haven't turned around, guys. I'm still going east. I'm still above the line. So from C to D, I'm still going east. At D, now I'm going west. So now I'm going to come back down. So at E, you make a cross that comes back down. And at F, I went back down further. And at G, I went back down further. Go and do the crosses first. Then you can do your flat lines. So you know, for that bit from A to B, I'm speeding up. So what must my gradient do? Steeper, curve steeper. So if this one goes up, this one's going to smile. That's the way I remember it. It needs to smile. Curving up. From B to C, what is the velocity doing? Stays constant. So that means my gradient must be constant. So you literally take out a ruler and you make sure that we can see, not dotted. You make sure that we can see, you draw a straight line. From C all the way to, from C to D. What do I know it must look like at D? Flat. So I know here at D it must be flat. So to get there, it needs to curve to be flat. And then it's increasing, but it's increasing negative. So it's gonna, it's a bit wobbly, needs to frown. Then from E to F, what's the velocity doing? Constant. So again, you take out a ruler so that we can see that you are drawing a straight line. And then from F to G, what's happening to the velocity? What must it be when it's at G? The velocity is 0, so it must be flat again. So to get to flat, I know it needs to curve like that. So guys, it really helps if you do the crosses first and then think, how do I get to that cross? Is it a curve or is it a straight line? And that's it. Happy days.